Okay, let's get going again. And we're working on money supply, money demand. But before we do that, I want to go back, since we've just had the exam, I want to go back to the Keynesian model and give you guys another example of the multiplier in the Keynesian model. Because I've been talking to a few students, and it seems that people are confused with some of the things I said, particularly about don't memorize the multiplier. If I had a different model, it would come out different. What the heck was I talking about? So I want to give another example of calculating the multiplier for what is essentially the same model, but with a different set of assumptions. Right? So what we had before is we had two equations. So this is before. Yeah. We had y is equal to planned aggregate expenditure. This is our 45-degree line. That is, in the economy as a whole, expenditure, output, and income have to be the same. Right? So y is income and production, and on the right we have expenditure. These have to be the same in equilibrium for the economy as a whole. And then our other equation we had was y is equal to c plus I plus g plus net exports. That was just coming from adding up all the things that people might buy. And we arbitrarily made these groups of consumers and firms and government, but it's really just all the stuff that anyone would buy, just dividing up all the anyone into different groups for our own personal convenience. And then to make the whole thing work, we added our consumption function. C is equal to, I can't remember what letter we used, C bar plus little c y minus t, where this we're thinking of as income, and capital T is taxes. And we did a bunch of stuff, and we got the multiplier equals 1 over 1 minus c. And of course, many of you tattooed that on your arm so that you'd be ready and never forget it, because it's just that important. But we didn't have to make those assumptions. And in particular, we picked a particular consumption function, which isn't fundamental to the story. But we need a story about why people buy stuff. But it doesn't have to be exactly that story. And that story in particular is a bit silly in many ways, of course. It's actually not as bad of an approximation as you would think, except taxes in real life don't work that way at all. Right? This is saying everyone in the economy has to pay us 20,000 euros in taxes. Doesn't matter if you're rich or you're poor or whatever, you got to pay 20,000 euros in taxes. If you lose your job, tough it up, 20,000 euros. You make $1 billion, good for you, 20,000 euros. It's just a lump sum tax. You pay the same tax, whatever, right? And that was to make things easy for us, but it's not the way the real world works at all. So we could change that to be more realistic. Have a new consumption function. Where C is equal to C bar plus C. But now, what we're going to do is we're going to multiply it by disposable income the same way we did before, the after-tax income. But now we want more realistic taxes. We want our taxes to be the proportional to our income. Like, let's say we had the 20% tax rate. If you make 100,000 euros, you pay 20% of that. If you make 1,000,000 euros, you pay 20% of that. If you make 10,000 euros, you pay 20% of that. Of course, real life is more complicated. There's bands and stuff. But if we just have like have this sort of marginal tax rate where you pay a percentage of your income, it's more realistic than what we had before. So your disposable income, we're going to say, is y minus ty, where this is income tax rate. Right. And so this whole thing becomes C equals C bar plus marginal propensity to consume times 1 minus t times y. That is, you have to pay a percentage of your income in tax. That doesn't affect your consumption because it's gone. But if you have more income, you pay more tax. If you have less income, you pay less tax. Okay. Not our tax system. Our tax system far more complicated, but it is more in the spirit of our tax system. Okay? And so I could just as easily have assumed this. And there's a million ways that I could make this consumption function more realistic. This is the first one that came to mind. Right? So in this case, we have our three equations. We have y is equal to planned aggregate expenditure. We have y is equal to c plus I plus g plus net exports. And we've got c is equal to c bar plus c 1 minus little t times y. Okay. Same story, more realistic taxes. And the way I'm going to solve this is the same way that I did before. I'm just going to put all these things together. I'm going to this is planned aggregate expenditure. Going to put planned aggregate expenditure in here, so I get y is equal to c plus I plus g plus net exports. Fair enough. Then I'm going to plug in my consumption function. I get y is equal to c bar plus little c times 1 minus t times y plus I plus g plus net exports. And now I've got an induced part and I've got an autonomous part. My autonomous part is all the stuff that doesn't depend on y. So that's this, 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 and this. None of these depend on y. So I'm going to have the autonomous part equals c bar plus I plus g plus net exports. That's all the things that we're not even hoping to explain in this little story. Or we are hoping to explain consumption, we are hoping to explain output, but we're not hoping to explain I, we're not hoping to explain G, we're not hoping to explain C bar, because these things we haven't made a story for any of them, right? And so without a story, we don't have anything to explain. It's just going to be A, okay? All the things that are outside of the model. Autonomous consumption. Autonomous spending, sorry. And so putting this all together, we get y is equal to A plus C 1 minus T times y. And of course, y on the right-hand side is income. And the y on the left-hand side is expenditure. And kind of output. Right, production. But of course, they're the same thing, right? So we have this letter that's standing in for various notions. On the right-hand side, the notion is how rich we are, how much income we have, and that affects our spending. But of course, for the economy as a whole, how much income we have and how much we produce are going to be the same thing. Never for individuals, well, almost never for individuals, but for the economy as a whole, they're going to be the same thing. Okay? And so now we can treat them as the same thing. Y is Y. Because we put all our equations together. After we put them together, then we can start treating them as identical. And so I got y on the right-hand side. I got y on the left-hand side. Let me put them both on the left-hand side. So I get y minus c 1 minus t times y is equal to a. Putting all the y's together, I get y times 1 minus c 1 minus t is equal to a. And so y, equilibrium output, is equal to a times 1 over 1 minus c 1 minus t. And this thing is our multiplier. Okay, importantly, not 1 over 1 minus c like you have tattooed on your arm. It's slightly different. Okay? Does it make sense? Can we do this? Is this legal? Well, we did one thing that was maybe suspect, is we divided, right? And we know that like subtraction, you can always subtract. Addition, you can always addition. You can always add. But division, sometimes you can, sometimes you can't. And the time when you can't is when you're dividing by 0. Right? That's not a thing you're allowed to do. That's saying there's something wrong with the math. And so we're wondering, as we go from this step to this step, are we dividing by 0? Because if we are, none of this is legit. But if it's not 0, we're fine. Okay, so it's 1 minus c. C is the marginal propensity to consume. That is a fraction. T is the percentage that the government takes in taxes. Now, potentially it could be anything. It could be 120% of what you make, right? It could be anything. But in real life, it is a fraction itself. They take a fraction of your income. So if we restrict ourselves to sensible marginal propensities to consume, that's going to be a fraction. If we restrict ourselves to sensible tax rates, T is going to be a fraction, say 20%, say 40%, 0.4, 0.2. So 1 minus T is a fraction. So it's 1 minus a fraction. So this is not 0. Right? So we can do this division. And in fact, it's a positive thing. 1 minus a fraction is going to be a positive thing. So we have a positive thing. It's going to be autonomous spending times this thing, our multiplier. So we found the equilibrium output. Now, does it make sense? What do we know? Well, we have two things that this multiplier depends on. It depends on the marginal propensity to consume, and it depends on the tax rate. Right? So let's talk about the marginal propensity to consume. And would we expect marginal propensity to consume going up to increase or decrease our multiplier? Well, how do we reason that? We say, well, what's going to happen, say, is the government's going to increase spending. They're going to buy some stuff. Stuff gets produced. Then the person who sold that stuff is going to feel rich, and he's going to do whatever a rich person does. And if marginal propensity to consume is high, he's going to spend a lot. And if it's low, he's going to spend very little. Right? If it's 0, he's not going to spend anything at all. Right? So the more he spends, the bigger this second round is going to be. And so the bigger the multiplier is. So the bigger C is, the bigger we expect the multiplier to be, given that it's below 1. Right? C is below 1. So let me go to the next page so we have space to play with this. So we have the multiplier. Like that. So our logic is, if C goes up, multiplier goes up. That's our logic. Is that true? Right. Well, if C was 0, this would be 1 over 1. The multiplier would be 1, right? Why? And we know this from our story, because the government goes out and buys something. They buy one thing. They increase G by 1. That produces 1 haircut. That's the 1. We spent 1. We got 1 in output. The barber feels rich, and he does whatever a rich person does. And in this case, when C is 0, what a rich person does is just sits on the money and puts it in the bathtub, rolls around in it, but doesn't spend it. Right? C equals 0 means when you get richer, you don't spend anymore. Right? This is Bill Gates. You give him an extra 100 million, he doesn't even notice it exists. Right? So, right. And then if C goes in the direction of 1, then the multiplier goes in the direction of 1 over 1 minus tax rate, right? In the limit, for your calculus people. And this is 1 over a fraction, right? And so that's going to be bigger than 1. So that's true. The same as it was before in our other formula. Right? With simpler formula, we multiplied by not 1 minus taxes, but just by 1. Because there was no marginal tax rate at all. Okay. What about taxes? If t goes up, what do we expect to happen? Well, suppose that taxes went all the way up to 100%. So when I make more money, the government takes it all. Okay. Then what happens? It means the government bought this haircut. Okay. That made output go up by 1. And now the barber has money, but he doesn't feel rich because he has to immediately give all that money to the government. Right? And so because he doesn't feel rich, he's not going to change his spending at all because all that money gets confiscated. So the more money we confiscate from him, the less rich he's going to feel. And so he's not going to change his behavior very much. And so we would expect that when tax rates go up, that the multiplier would go down because people don't feel as rich. Remember, there's this whole chain. You buy something from me, I feel rich, therefore I do whatever a rich person does. And if I spend more, the more I spend, the bigger the multiplier. Okay. When we changed C, we said, person bought the thing, I feel rich, I do whatever a rich person does, I spend more because C is higher. And so therefore there was a bigger multiplier. Here we're saying, spend some money, I get it, but I don't feel very rich because most of it's being taken in taxes. So I don't feel as rich. Yeah, I do whatever a rich person does, but I don't do very much of it because I don't feel very rich. The government took the money. And so the multiplier is smaller. Okay. And we can see just in the formula that t is entering the opposite way of c, right? If c is minus c, it's going to be plus the tax bit. So it's going to have the opposite effect. We can do it with examples. We can say if taxes equal 0% taxes, then the multiplier is 1 over 1 minus c, just like we had before in class, right? Because there was 0 marginal taxes. You had to pay this lump sum, but you didn't have to pay on your income. That's the same as having little t equals a 0. And if t goes in the direction of 1, they take all of our taxes, all of our income in taxes, then the multiplier goes in the direction of 1 over 1 minus c times 1 minus 1. So this is 0. So just 1 over 1 is equal to 1. Because if we have a 100% tax rate, what that means is that any extra income I got is just taken by the government. And so the government buys something, that one something gets produced, that's the one. And then I don't feel rich at all because they just took all my money. And so I don't change my behavior at all. And so there's no second stage at all. So the higher we make the tax rate, the lower the multiplier goes. So we're now, I can change things in all sorts of ways, right? I can make, for example, imports depend on how rich we are, which makes sense, right? If you're a rich person, you're buying lots of stuff, and therefore you're going to buy more stuff from foreigners as well as domestically, right? And so that's going to be a little parameter And then imports are going to be a function of Y. Right? There'll be a little parameter floating around, and that's fine, but it's going to affect the multiplier formula. Right? I can make, well, that's sort of the obvious one, but I could make imports depend on the size of our country. I can make all kinds of changes about how we tell our stories, add more nuance to the story. And every nuance that I add to the story is going to change this formula in some way. It's not going to change the fact that if the marginal propensity to consume goes up, the multiplier will go up. Right? It's not going to change that basic fact. The directions of things will be the same, but the formulas will get more complicated the more complicated of a story that I tell. Okay? There's nothing set in stone about any of these formulas. It's just something that we derive for a particular example story we're trying to tell. But the general direction of things, that telling of the story is important. Right? So that I can give you any one of these little stories. You could do the math if I gave you a formula, but also you could just reason it out, which direction it has to go from this story, right? Government buys something, people feel rich. Do they feel a lot rich? Do they feel a little rich? They're going to change their behavior. They're going to do whatever a rich person does. Does that mean they're going to buy more domestic products or less domestic products? How much more? If they buy a lot of domestic products, the multiplier is going to be big. If they buy just a few domestic products, the multiplier is going to be small. And the 1 did not show up here. Right, so, any questions about this? Okay. Page 51. What do we got going on here? The question is, do we have the time to finish this up or not? Yeah, I think we do. Okay, so here's where we were. Almost where we were. Where we were. Duplicate the slideshow. Happy days. Okay. So we have money demand, and we have the money supply, and we have a central bank that has the ability to just control the money supply, move it left, move it right on a whim. Which means, in the end, what they can do is if they want the interest rate to go down, they just print more and more money, and we move along this money demand curve until the interest rate gets where they want it. And if they want the interest rate to go up, we just remove money from the economy, we move up the money demand curve, and we get the higher interest rate that we want. Now, there's a bunch of stuff going on behind the scenes here that we didn't really talk much about. We say the interest rate, but we know in real life it's more complicated than that, right? This is not following me at all. There's many interest rates that exist in the world, and so they don't all necessarily follow each other. Some books say, well, let's talk about a particular interest rate, the interest rate that banks loan each other money. And they say that's the interest rate we're talking about. It's not really going to solve our problem because we're going to be, in the end, interested in investment. And the investment is not going to depend on the rate that banks charge each other. It's going to depend on the rate that Hewlett-Packard has to pay when they borrow money, or the rate that they get if they loan people money. Right? It's going to depend on what the corporations the interest rate that they get. So it's not clear which interest rate we should be talking about because this is a simple model and the world is more complicated than that. And a lot of modern monetary policy is trying to deal with these complications. Like, okay, we can control the interbank rate pretty well, but that doesn't necessarily translate into the interest rate that firms actually get charged when they issue bonds. Right? And there's various interventions to try to deal with that. For example, central bank buying corporate bonds instead of government bonds to try to break that connection and go directly for the thing that they're interested in. For our point of view here, I want you to be aware that it's messy and that there's many interest rates out there, but by and large, I won't say most of the time, but a useful way to start thinking about them is to think, okay, we can say change the interest rate that banks charge each other. That's a cost for the bank, and that's going to be passed on to other borrowers. So if we lower this interest rate, in the end, it's going to lower a lot of the other interest rates too. And that we're going to sort of go with that. But a lot of issues in modern macroeconomics are about, in modern monetary theory, in central bank behavior, is about making sure all these links add up, right? So making sure that when we change this interest rate, it actually also changes the interest rates that firms are paying as well. But for the moment, and this is broadly true, that when we change this interest rate, when we do this, it's going to change all the interest rates in the economy. Okay? It does tend to, but doesn't always, and that not always is a real issue. But we're going to skim over it here just to get the broad strokes of what's going on, but be aware that there's details here that do actually matter. Right? So we have the central bank is now able to control the interest rate. And we always talk about it like the central bank sets the interest rate to this, the central bank sets the interest rate to that. Of course they don't. They change the money supply in such a way that people buying and selling amongst themselves charge the interest rate that they want them to charge. Okay, so they're manipulating the market in a sense to get them to charge the interest rate that they charge. One other thing to point out is that we have been ignoring prices here. And prices are going to be important. They are important, but they're not in the model yet. Right? Remember, we have so far a model where we have preset prices. Right? So prices are fixed. And so we didn't have to worry about the price level because it's not changing in our story. But as we get to more sophisticated stories, we are going to want to think about this in a different way. And so we're going to typically say, this is money supply divided by the price level. So real money supply. Right. At the moment, it doesn't matter because the price is constant. Right. And so we can change the amount of money in the economy, but if we double the amount of money in the economy, presumably, eventually, prices are going to double as well because we're going to have twice as many euros floating around with the same amount of stuff. So it's all well and good to say that we can pick the money supply wherever we want, but in fact, if we double the money supply and then prices double, it's going to go right back to where it was before. Okay? So there's a lot of argument. Like one of the big areas of argument in macroeconomics is how effective monetary policy can be. Can we influence the economy, the real economy, with the money supply, or can't we? And there's all kinds of empirical evidence, and the fact of the matter is, well, I'm going to say the fact. Like what I think that the fact of the matter is that different episodes have different things going on, and different effects are more important now versus other times. But one of the issues is, how quickly do these prices change? Right? So if prices change really quickly and we double the money supply and instantly prices have doubled, we haven't done anything real to the real value of the money that's out there. And remember, the whole point of this, whole point of holding money is to make purchases, because money is the stuff that makes purchases easy. And so if the actual purchasing power of the money didn't change, nothing really changed in the world, right? It's just we doubled all the numbers. If prices stay the same, yeah, we've lowered the interest rate. But if prices didn't change, if prices doubled as well, there's still the same real spending power of money out there. And the purpose of money is to spend. And so it's not really, we don't really have more spending power out there. We have more euros, but not more spending power out there. And so one of the issues is how much we can actually change the spending power and for how long. People who think prices take a long time to adjust think that this link in the chain is strong, and therefore it's likely that money can affect output. But to the extent that you think prices change quickly when we increase the amount of money, then this link of the chain, well, nothing's going to happen. You're going to change the money supply, and the real spending power of money is going to stay the same. Okay, so the shift assumes that the prices didn't change. Real life, they certainly will change. It's a question of how much and how quickly. There's going to be other links in the chain, right? We change the money supply. Does it actually change? Does the real money supply change? And then that affects the interest rate, but is that the interest rate that firms actually get charged? And so do the interest rates that firms care about change, even when we change the money supply? Or did we really lower the interest rate that matters? And then when there's a lower interest rate, how do firms respond to that? Well, it depends on what they think business conditions are in the future. Right? And so if they respond to that and they increase investment, great, that will affect the real output. But there's a lot of links in this chain. Like it's the increased government spending output went up, that was really direct. They're just buying something. Right? But here we have a very indirect link between playing with the money supply and its effect on output. And so there's a lot of ways for that to go wrong. And so a lot of modern monetary policy is about trying to target these links and make sure that those links are strong so that when we change our level of the money supply or whatever we do, we actually have effect on real things. Okay? We're going to make it simple and say for at the moment that the price level doesn't change, continuing our Keynesian model, but we are definitely going to be changing that in the future. Okay, future, like, yeah, a couple weeks. Now I will say, like, you guys can have any book. And so a lot of books, and my preferred method is to say, let's put the prices there, right? But we could have instead put money over prices here. Let me put it in different color so that that is, we're wondering what the real money supply is. And then the supply of real money is. And so then this becomes, and for real money. Right, so demand for spending power. We can divide anything by P we want because at the moment P is a constant. Right? So just be aware that different books are going to do this in a different way. We'll deal with that in more detail when we get there, when we actually start changing prices. But at the moment, we're keeping prices the constant. So it doesn't matter how we think about prices because they're always the same anyway in our story. Okay. Simple story first, more complicated story next. Okay, so we have our central bank that can control the interest rate by increasing and decreasing the money supply. That's great for them. And so we always talk about it in terms of the interest rate, but in fact, what they're doing is changing the money supply. That affects the interest rate. Okay, now that's just saying the same thing. Okay. Blah, 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 blah. Okay. So here is not like a typical exam question, but one of the harder exam questions, because I found that this sort of question is a question that it's lovely to ask because it tests a lot of things, but I've in the past had students like couldn't even figure out what the heck's being asked, much less how to answer it. So I'm going to take you through one so you see what kind of things you need to know to ask this question. So this is, in a sense, a harder question because in order to get it right, you need to know more stuff, right? So there's a fair amount of stuff embedded in this question. But it's a question like, the required reserve ratio is 10%, the desired reserve ratio is 20%, banks have 10 billion in reserves and 5 billion in cash is held by the public. What is the money supply? Well, God help us, right? It's just so much stuff, so much stuff. Well, how the hell? So the first thing to do is to say, okay, we're given all these reserve ratios, but in fact, the banks are going to be holding some number in reserve. They're not going to have two things in reserve, right? And so we have to figure out what reserves the banks are actually going to hold. And so we're told that the required reserve ratio is 10%, but banks want to hold 20%. Okay. And since they want to hold more than they're required to hold, they can do that. They can hold 100% if they want. Like, no one's going to stop them. And so in this case, the 10% is absolutely irrelevant, and we can cross that off. It doesn't matter at all because banks are actually going to be holding 20%. On the other hand, if the desired reserve ratio is 5%, well, they want to hold 5%, but the law says they have to hold 10%, the 10% would be the relevant one. Okay, so it's not like the desired one is always the right one. It depends on which one's higher. We're going to be with that. Right? So here, the banks are going to be holding 20% in reserve. Okay. What do we have on the next page? That's just what I said. So they're going to hold 20% in reserve. So for every €1 in the bank that people think they have in the bank, remember, if you think you have money in the bank, That's part of the money supply. So for every €1 that people have in the bank is going to be holding 20 cents of that. Right? So loans are going to be 4 times as big as reserves. Right? So that's kind of neither here nor there. We could cross that sentence off and we'd still be fine. So for every euro of reserves, every euro that the bank has in its vault, the total deposits are going to be 5 times that. Right. Now, I put in a euro, they're going to keep 20% in the vault, but I still think I have a euro. That's 5 times as big as the amount of money in the vault. So we are told that they have 5 billion in reserves, and so the total deposits are 5 times that. Total deposits are 50 billion. But plus, people are also holding cash. So we add in the cash. Money supply M1 is the total amount that people have deposited plus the cash that they're holding. And that's 55 billion. Now, there's loads of ways to answer this. I could give you the money supply and ask you what are the reserves, and right, you go about this various ways. But what do you need to know? You need to know, okay, how do these reserve requirements and desired reserves work? Right? You need to know from that, you need to be able to go between bank balances, the amount that people have in the bank, and the level of reserves that the banks hold. You need to know that the money supply is everything everybody has in the bank plus the cash. Okay. And so you need to put a fair amount of stuff together to answer this sort of question. Okay. Now, you will see on the old exams a fair number of these sorts of questions, so you can try it out yourself. It's worth giving it a go over the next weekend or so, just to get familiar with it. It is not hard once you get familiar with it, but it's kind of impossible if you don't. So it's okay. All right. That's what we have for money. And what we're going to do next is we're going to put all this stuff together that we have so far. So we're going to take our money market, which is going to be sort of our stand-in for the entire financial system. Obviously, entire financial system more complicated. But we have the finance side, which is moving slips of paper around. And we have the real side, which is the Keynesian cross diagram, where stuff is actually getting produced. And we want to see how the financial side and the real side interact with each other. And that's something called the ISLM model, which is just taking what you know at this moment and putting it together. The graphs are kind of fun, but we're just putting all the stuff that we have together. So the next lecture or two are going to be stuff that you know, but put together, packaged in a different way to give you a new graph to be able to work the financial system and the goods market together in one story. Okay. I will let you go and see you next week.